Hello everyone, and welcome to the demo presentation of ProLift, a tool for discovering causal rules from event logs. So once you upload your log here, you need to specify the column types. We have 6 types, which are controllable, uncontrollable, outcome, group identifier, ignore, and order by. In my example, which is a loan application process, the application type is an example of an uncontrollable attribute. The case ID is the group identifier. The activity is an example of a controllable attribute, which can be influenced by the organization running the process. Next, we need to specify what we mean by a positive outcome. So here in my example, if the column selected is equal to true, we say that that case is successful. So what do we mean if the case is treated? To say that, we say, let's say that our treatment is sending multiple offers to a customer. So in my case, if the activity is equal to this value, in a case not once, but twice at least, that case is treated. And next, I will name my model configuration page, which is called new model, for example. And that will take us to the data analytics tab, which will show us some basic analytics based on the specified treatment and outcome configurations. So in the first bar chart on the left, we indicate the number of all types of outcomes in relation to the length of a given case. So for a case, cases that were of length 26, 7 have been treated, 8 have not been treated, 7 were successful, and 8 were not. In the other bar chart, we show the number of positive and negative outcomes in relation to the number of interactions or events that happened before the treatment was applied. So if the treatment was applied, the number of interactions before the treatment was 20, 7 of those cases were successful and 2 of them were not. Next, in the data balancing section, we can specify the cutoff percentile, which means how much of the data we want to use. So here we want to use 95% percentile of the data. In max delta, we can say the maximum percentage of difference between the minimum and maximum value in the confusion matrix shown below. So if I change that to a higher number and we rebalance the data, we see that we have more variation here. Next, we specify the model settings. First, we specify the evaluation function, which here is the callback divergence. Then the depth of the tree, because we are training an uplift tree. Then the minimum number of samples within each leaf, the minimum number of treatment samples, and a regularization term. So based on these, we build a uplift tree model, and that will give us some rules. So the green rules say that for these subgroups of cases shown here, if the treatment is applied, the chance of a positive outcome increases by this number, by this percentage here. In the red rules, if we were to apply the treatment to this subgroup of cases, the chance of a positive outcome will actually decrease. Thank you for listening.